Hello students, welcome to today's class. I hope you all are doing extremely well, and I really hope that you are going through all the videos that are being uploaded. Well, after our last class we have discussed the indifference curve, and today we will discuss some more concepts which are related to the indifference curve. Well, the first thing today that we will discuss is the concept of indifference map. Is the concept of indifference map. Well, we already know that what an indifference curve is. An indifference curve is a locus of combination of two goods that yields same level of satisfaction to the consumer, and the consumer has no other reason to choose one combination over another, because the combinations outlined by the curve, any combination you can choose, the consumer can choose, and that combination will give him the same amount of satisfaction. Now, well, hang on, let me write it, the indifference curve definition. That gives same level of satisfaction. So now the indifference curve that was being drawn, that already we have seen in our last class, that related to a indifference curve schedule, a tabular representation of all those combination of goods that yields the consumer the same level of satisfaction. Now the way we have drawn the indifference curve, likewise we can outline some more combinations. In the similar way, we can outline some more combination of goods and services that will give the consumer some more or less level of satisfaction. The procedure that we will follow while making the indifference curve schedule are same as what we have already seen in our last video. So with that ideology, we can draw various kinds of indifference curves which will give similar kind of indifference curve, like that were the downward sloping indifference curve and kind of convex to the origin. So all those similar kind of indifference curve we can draw with the help of different indifference curve schedule, and they can give us that higher or lesser amount of satisfaction to the consumer. Because if we draw a similar set of indifference curve, we will find that some curves are lying above one other and some are lying below one another. So in that way we can outline a number of indifference curves in a single diagram. So when a number of indifference curves, a family of indifference curves are drawn on a single diagram, we get the indifference map. So let me write the definition. to the So here it is, my students, that we can draw similar set of indifference curve that gives more or less level of satisfaction to the consumer. All those combinations that are lying on a single indifference curve, single IC means the indifference curve. Single indifference curve provides same level of satisfaction and a different level of satisfaction represented by different ICs such that a higher indifference curve will give more level of satisfaction and lower is represented by lower level of IC. Well, let me show this graphically. So first we have outlined two axes, vertical and horizontal. In the horizontal axis we are measuring good x and in the vertical axis we are measuring good to y. So we can draw similar set of indifference curves like this. All of the indifference curve that I have drawn just now in this diagram looks more or less similar to one another. But what is happening? One indifference curve is above another, or some other is lying below other. Like, let me name them IC1, IC2, IC3, and IC4. So you can see IC3, 2, and 1 are lying below IC4, and similarly there are some indifference curves like IC2, IC3, IC4 which are lying above IC1, and that's exactly what I have written right here, that there will be some curves which will be lying above some other curve, and there will be some curves which will be lying below some other curves. Like if you compare IC2 and IC1, they are below IC4 and IC3. If you compare this IC3 and 4, they are above IC2 and 1. So my ideology is that, or the ideology, not my ideology, sorry, the ideology behind the indifference map is that if any combination is chosen any of the particular indifference curve, that could be indifference curve 1, 2, or 3, or 4. If we choose any combination on a particular indifference curve, say suppose it is IC1, or we are choosing on IC2. Suppose that we are choosing a combination on IC2. So no matter at which point we choose, we can choose at this point, or this point, or this point, or this point. So any point we choose on a particular indifference curve, that will give us the same level of satisfaction. But if we do something like that, that we are choosing on a different indifference curve, so that will give us some different level of satisfaction, such that if we choose any combination on IC3 or IC4, it is higher than IC2, then it will provide us some higher level of satisfaction. And if we choose a combination on IC1, then it will provide us lower level of satisfaction, because it is on a it is lying below IC2. So that means higher or further the curve is away from the origin, higher level of satisfaction. The IC4 is lying much more further than the origin. It is much more away from the origin. So the highest level of satisfaction is represented by IC4, and IC1 is much more closer to the origin. So that means this IC curve, indifference curve, is representing some lower level of satisfaction. And when we will draw this kind of set of indifference curve in a single diagram or in a single graph, we get the indifference map. So in indifference map, basically what happens, a family of indifference curves are drawn, and such that further the curve is away from the origin, higher level of satisfaction is represented, and if a curve is closer to the origin, lower level of satisfaction is represented by that curve. Likewise here, IC4 represents higher level of satisfaction, and IC1 represents some lower level of satisfaction. So this is it, the indifference map. So I'm wiping it out. If you want to write it down, you can take a screenshot. Just rewind this video a bit and just take a screenshot. Okay. The next thing or the last thing we will discuss in today's video is various properties or characteristics of indifference curve. properties of indifference curve. They are also can be referred to as characteristics. Okay. To describe the characteristic, I need this indifference map once again to make you understand even better. Yeah. Okay. The first characteristic is that so the first characteristic we can easily find that indifference curves are downward sloping. So it is a simple fact that if we want to consume more of any particular good, say suppose we want to consume more of good egg. Suppose we are consuming at this point. At this point, the consumer is consuming AY1 of good Y and AX of good X. Now, if you want to consume at this point more amount of good X, BX, if we want to, this is point A and this is point B. So, if the consumer wants to consume at point B, that means he wants to consume more of good X. So, in order to consume more of good X, he has to sacrifice more of good Y, and he has to come down from AY to BY. So, this is the reason for which indifference curves are downward sloping. That means, in order to consume any one particular good in a bulk quantity, the other good, the consumption of other good has to be sacrificed. The second thing we find that the indifference curve is convex to the origin. Axes are convex to the origin. Indifference curve, here axes represent indifference curve. You students, please do not write axes, please write in full indifference curve. Here, for sake of simplicity and to save time, I am just writing axes in a shortcut way, but while writing in the exam script, please do not write axes, just write indifference curve. Well, indifference curve is convex to the origin due to the operation of diminishing marginal rate of substitution. The marginal rate of substitution, I have given you a small idea that it is the amount sacrificed in order to consume one more extra unit of any other good. Say suppose I want to consume one more extra unit of good X. I want to consume one more extra unit of good X. So in such scenario, we have already learned that to consume good X more, we want to sacrifice good Y. So how much of Y we will be sacrificing? So that thing is represented by the marginal rate of substitution. That it is the amount sacrificed in one commodity. One commodity here is the Y commodity, in order to consume one more extra unit of other commodity, one more extra unit of X commodity. So, and this MRS curve, MRS concept is always diminishing. The marginal rate of substitution is always false. Unlike the marginal opportunity cost, where we have seen that the opportunity cost is rising again and again from each unit, but here the marginal rate of substitution is decreasing. So due to the decreasing MRS, marginal rate of substitution, indifference curves are convex to the origin. The next 2 points are basically related to the indifference map. That from the indifference map, we have found that higher indifference curve represents higher level of satisfaction. So this is one more characteristic. Higher IC represent higher satisfaction. Now, students, just look at this diagram. I am drawing another indifference map. This is IC1 and this is IC2. Now, in this graph, can we say which curve is above and which curve is lower? Up to this part, indifference curve 1 is lying above and indifference curve 2 is lying below, and in this part, indifference curve 2 is lying above and indifference curve 1 is lying below. And at this point, say this is point P. At point P, both the curve intersected each other. One curve cuts another curve, that is the point of intersection. And at that point, what happened is that both the curve intersected, and as a result, we cannot say which curve is lying above and which curve is lying below. So if this happens, it will violate the axiom of dominance. That means axiom of dominance means who dominates who. The larger one dominates the lower one. The superior one dominates the inferior one. Now, in this indifference map, this one, indifference curve 3 is the superior one because it is lying further away from the origin. And it is dominating IC1 and IC2. But here we cannot say anything like that. So we can give a conclusion that ICs cannot intersect each other. So these are the 4 characteristics of indifference curve. I hope you have understood these concepts well, and if you find any trouble with these concepts, the indifference map and the properties of indifference curve, feel free to comment below and I will reach out to you as soon as possible. Till then, stay safe, stay strong. Thank you.